Hi students, welcome to Science Extension and Module 3, the Data, Evidence and Decisions. This is video number 11. We're going to briefly talk about data cleansing. This has been part of a series of applying appropriate performance measures to the statistical analysis of quantitative data sets obtained from conducting a relevant practical investigation, and this time we're going to be looking at data cleansing. So I guess the first thing we need to do is explain what data cleansing is, and this is the process of identifying and removing or correcting errors and inconsistencies in the data. So what we're trying to do here is we're trying to improve the quality of the data. There can be several reasons why we want to do this. We might want to reformat the data. For example, we might have extracted some data from a public data set, but it's in CSV or comma separated variable format. We want to be able to do some manipulation in Excel, so we maybe need to just change the file extension to an XLS or an SLSX in order to be able to be read and then played around with in an application like Excel. Sometimes we're removing blanks, so in certain types of statistical tests or some analysis of our results, we might not be able to deal with data where there are zeros or where there are blanks. And so therefore, if we remove some of those, if data sets are incomplete, we can remove those blank lines or remove cells or maybe even remove a line that has some blank cells in order to make sure that all of the data can actually be analysed for all of the variables that we're interested in. One that's possibly a little more controversial is the removal of outliers, and there can be good reasons why you might remove outliers from your data, but you also need to be aware of why you're doing that, and preferentially that you actually identify that somewhere during your analysis or even during the results that you've identified why you've left certain data out of your final results and therefore your ultimate analysis of those results. And the reason this last one is a little bit challenging is because you may have a reason for removing outliers or even removing certain parts of the data set that actually mean that it preferentially gives your results more meaning, or maybe you're able to determine a significant test statistic where you may not have been able to determine one if you'd left all the data intact. So it's very important that we make sure that we're not just cherry picking data in order to make sure that we get the result that we want at the end of it, but that when we're doing the data cleansing process, that we make sure that we're only removing data that we have good justifiable reasons for removing. So one of the things that's important as we think about the challenge of data cleansing is, are we removing incorrect or missing data? Or are we actually removing data that affects the calculation of our test statistic and hence may actually change whether we reject or accept our null hypothesis? There's a lot of information that you can look at around data cleansing processes. You can see a range of different types of things that happens with data. Obviously, this happens in a much larger scale if we're looking at public data sets where there's big data, where there's lots and lots of information. You probably don't want to be going through line by line of a big data set and trying to work out where everything is. You may write some code or you may have some rules that enable the data set to be cleansed, to ignore any values which are blank or possibly even zeros. They may affect your results as well. So there's a few different areas that you want to have a look at. Work through things like checklists. Checklists can be quite useful when you're looking at what sort of data you want, what sort of data you might need to remove in order to improve the overall quality of your data. Even something like differences in spelling can creep into data, and it might mean, to take a very simple example, if you misspelt the color blue, you might have a BLUE group and a BLEU group, and both of those should obviously be all together, and generally speaking are indicating the same things. So it's important to identify if there are simple things like that maybe that's part of your data cleansing process where you're trying to make sure that all of the data that you have is in a format that can then be grouped, organized, analyzed, and subjected to statistical testing. There's a number of papers that are useful for you when you're having a look at data cleansing. This is an interesting one on reviewing data cleansing methods for big data. Again, here's the abstract. You go from the abstract to work out whether you want to go into this paper in a little bit more detail to determine whether you need a bit more of an understanding of what sort of things are being done to cleanse data. So the abstract reads, massive amounts of data are available for the organisation which will influence their business decision. Data collected from the various resources are dirty, and this will affect the accuracy of prediction results. Data cleansing offers a better data quality, which will be a great help for the organisation to make sure their data is ready for the analysing phase. However, the amount of data collected by the organisation has been increasing every year, which is making most of the existing methods no longer suitable for these big data sets. Data cleansing processes mainly consist of identifying errors, detecting the errors, and correcting them. Despite the data needing to be analysed quickly, the data cleansing process is complex and time-consuming in order to make sure that the cleansed data have a far better quality of data. The importance of domain expert in data cleansing process is undeniable, as verification and validation are the main concerns on the cleansed data. This paper reviews the data cleansing process, the challenge of data cleansing for big data, and the available data cleansing methods. So check that one out if you're interested. Finally, it's worth having a look at a few questions where we can, and this was a question that came out of the 2023 HSC. It was just one part of question 2, but you can see that there's some data here, and you can also see that there's some important information. And the question that we need to suggest ways that the data could be further cleansed for the purpose of the student's investigation, and here a justify your answer. In order to understand it, we need to read some of the information about it beforehand. So there's a lot of source data that you'll find in your exam, and also some information about that data. It's important that you try and get your head around that. So you don't necessarily have to understand what's going on in terms of something that you've done before, but what you should be able to do is to read through the information, process that information, try and understand what was going on, and then see if there are some conclusions you can make. So a group of students is investigating the relationship between temperature and the percentage of hydrogen stored in adsorbents. Adsorbents are solid materials that can store hydrogen. They found that a research company had publicly released data on thousands of adsorbents as 2 data sets. 1, a raw data set which is intended for use by scientists, and 2, a derived data set which had some data processing completed and was intended for use by students. And source 1 shows a part of the derived data set that the students plan to use for their investigation. The investigation will focus on 2 types of adsorbents, type A and type B. The adsorbents cannot be used at temperatures above 50 degrees, and we need to suggest ways that the data could be further cleansed for the purpose of the student investigation. So when we're going through this, we need to try and find out what are we actually looking for. So we're trying to focus on the effect of 2 different types of adsorbents, and the measure that we're interested in is adsorbents are solid materials that can store hydrogen. So we want A and B, so we want to make sure that we have samples of A and B because we're going to compare the 2 different types. We're interested in the effectiveness of these adsorbents, which means we're interested in the amount of hydrogen stored. So that's the measure of what it is that tells us something about the effectiveness of each of these different types of adsorbents. Now, the problem that we have, of course, is that you can see if we look at the hydrogen stored, there are a couple of blanks. If you were going to try and cleanse this data, one of the first things that you would want to do is remove those rows that have blanks in the hydrogen stored, because the measure that you're going to use for the effectiveness of these adsorbents is how much hydrogen they store. That's our definition up here. Adsorbents are solid materials that can store hydrogen. So we want to know how much hydrogen's stored. That's our measure of their effectiveness. But in order to do that, we actually have to have a value. So where we have 2 rows here where there is no information, that's not very helpful to us. So you would remove those 2 rows. So I would remove number 4 and number 7 here from the data. So that's a way to cleanse the data, is to remove those rows. And then a justification is that because we're specifically interested in the effectiveness of the adsorbents, that is how much hydrogen they store, because there are no values, there's no use in keeping that data in there. Now there's one other thing which I've almost obscured by my little line here, but one of the things that's important is the adsorbents cannot be used at temperatures above 50 degrees. So what I'm going to do is I'm going to read down my little list, and I'm also going to have a look at this particular one here, this value right here. So you can see for number 6, we have an example of type A. We have a temperature of 110 degrees. We have a value for the stored hydrogen, and we have a surface area, and we have a pore volume. So we have all of the data that we need here. The problem this time is if we're looking at the effectiveness absorbance that cannot be used above 50 degrees, then that means that 6 must also be cleansed from our data. It's not useful to us because the value of the temperature that gives us these results is outside of the set that we're looking for. So these are the sorts of things that we want you to start looking for when you are thinking about cleansing your own data sets, that you think about what is the question you're trying to solve, what variables are you interested in, and what sets or what repetitions have full sets of data, and are there any of those sets which maybe, like these ones, you can just eliminate because there was no conclusive information about the variable that you're specifically interested in. Thanks for watching.